Yes, I welcome you all for another presentation on control system subject. In today's presentation, I would like to explain you the next classification of compensator circuit, that is lead lag compensator, or sometimes also called as lag lead compensator circuit. As we have seen in our previous presentation why the compensation is required in control system. Basically, the compensation is required in order to bring the circuit as more stable. Say for example, if any given control system or any given system is performing or is under uncontrolled, means unstable, then in order to make that unstable system as a stable, the compensation is very much required. As I have discussed in just previous presentations, if you refer those, then in order to improve the accuracy and the steady state response, and in order to bring the system into stable condition, a compensator circuit widely employed in control system concept. Thereby, the stability will increase, the performance of the system will also increase. Right. In previous presentations, we have seen the performance of both the phase lag network as well as phase lead network. In today's presentation, we will see the combination of these two, that is what lead lag compensator circuit. In these circuit, both lead network as well as lag network will be cascaded to each other. Thereby, okay, so again it performs, it gives a good performance, and then thereby the stability will be increased with this lead lag compensator, right? And in this presentation we will see the transfer function or the basic electrical circuit of a lead lag compensator, and thereby we will see how the transfer function of this lead lag circuit is looks like, right? Let us go into the subject and we will see the basic circuit representation and its transfer function, right? We'll see. So in today's presentation, we'll see the lead lag compensator circuit. This is the lecture number 53 from our control system subject, and we are discussing about the various compensator circuits. And so far we have covered the lead compensator, or also called as phase lead compensator circuit, as well as phase lag compensator circuits. These two type of compensator circuits we have discussed in our earlier presentations, and we have seen the basic electrical circuit as well as their corresponding transfer function. And in this today's presentation, we will see the basic electrical circuit of lead lag compensator circuit, and we will see its transfer function, right? So we will see the basic electrical circuit of a lead lag compensator. So it is a combination of both lead as well as lag compensator actually. So the circuit of lead lag is something like this. It is the resistance R1 will be there, you can call it as R1, in parallel with capacitance C1, clear, as well as it has its parallel combination of R2 and then capacitance C2, right? This is a simple circuit, and here this is what your Vi of t, means input voltage normally, as well as this is what your V naught of t, it is output. Clear? So this is your input and this is what Vi of t is your input, V naught of t is your output. In general, R1 is the resistance element, C1 is the capacitance C1, right? R2 and then C2. Let us assume that this is a loop, one loop actually. Call it as something. I1 is the current flowing through this I of t, otherwise you can call it as current as I of t, right? This is what it consists both your lead as well as the lag, right? Is it not? So okay, it is a combination of both lead and lag actually. Therefore, so generally at low frequencies, the phase lag characteristics is observed actually. Okay, generally at low frequencies, the phase lag characteristics is noticed in the output of this particular circuit, as well as at high frequencies. At high frequencies, we have the phase lead characteristics. Okay, at high frequencies, the phase lead characteristics will be observed, as well as at low frequencies, the phase lag characteristics will be noticed. That's why, as we have seen, right, in our earlier presentations. Now we will see how the transfer function of this particular circuit looks like. The transfer function is obviously, as we know, that the transfer function is nothing but the ratio of V naught of S by Vi of S. This is what the transfer function basically, and we need to find out what is the ratio of V naught of S by Vi of S. So here, as here both R1 and C1 are there in the parallel combinations, right? Then assume that I of t, you take the current expression here, I of t. What is the current flowing through this element? You write the expression for I of t here, and again for this branch you consider the V naught of t. Your V naught of t is nothing but the voltage across this branch or this terminal R2C2, nothing but the same V naught of t will appears at this node. If you consider the node here, the same V naught of t appears here, or otherwise the same you can represent in this way also, right? So from this actually circuit diagram, I simply can write two important equations, right? Just remember that if you write the current expression I of t here, so similarly this Vi of t is nothing but you can represent here also the same at this particular node if you consider, or okay, Vi of t will be appeared here, or otherwise you can write here, nothing wrong in this. So for this initial, you write the current expression I of t as I of t from here. I of t can be written as how? Tell me. C1 into it is d by dt of what actually? Vi of t minus your V naught of t, right? So here I of t is equal to, means the current flowing through this. I am writing the expression for I of t. I of t is equal to, from here actually, I of t. And what is this I of t? Right? So here my total I of t is nothing but C1 into d by dt of this Vi of t minus V naught of t plus what you will get actually? Plus it is 1 by R1 into Vi of t minus V naught of t. You can call it as equation number 1. This is something I am writing I expression. I is equal to, from your Ohm's law, V is equal to I into R, and this implies I is equal to V by R. It is voltage by current formula. I is equal to V by R. So that's why I is equal to voltage by R, V by R form. If you write capacitance, C into dV by dt, current expression. Therefore, this is, I can write the expression here, the current I of t can be written as like this. And similarly, if you write the V naught expression here, if you write the expression for V naught is equal to V naught of t is equal to, you can write R2 into I of t, the same current I of t, assume that I of t plus 1 by C2 into integral of I of t dt. This you can call as equation number 2. Now we can call as equation number 2, right? These are the two expressions we can have from this circuit actually. Now, very simple. Now apply the Laplace transformation to these both expressions, and thereby you can find out the relation for V naught of s by Vi of s actually. Because in your competitive examinations, you need not to worry about the derivation part. In fact, as far as your academic is concerned, means if you are appearing for your regular university examinations, you need to practice the derivation part of to find out the transfer function, or otherwise as far as your competitive examinations, the final output expression is required, very much important to remember, right? If you apply the Laplace transformation, equation number 1, then it becomes what actually? It is I of s. So the time domain, t domain, can be converted into s domain after the application of the Laplace transformation. Then it becomes I of t becomes I of s. It is C1 into d by dt is nothing but s basically, and then it is V I of s minus V naught of s, clear, plus it is 1 by R1 same V I of s minus V naught of s. This is what? After application of the Laplace transformation. And similarly, if you apply for the second expression, it becomes V naught of s is equal to, it is R2 into I of s plus 1 by s into C2 into I of s. Clear? So you can call this as equation number 3, this expression as equation number 3, and you can call this as equation number 4, let us say. And after calculating simple calculations from these two expressions, everything is in terms of I of s and Vi of s, V naught of s is there, everything is there. And with your knowledge which we have studied so far, so you can obtain the relation very simply, V naught of s by Vi of s. If you equate and these two equations, from these two equations, if you simplify, finally I will write the expression for your V naught of s by Vi of s, nothing but the transfer function is something like this actually, s plus 1 by tau 1. The final expression I am writing actually, because it is something lengthy. If you simplify the final derivation, I think this I will leave you for your practice. You definitely can do it, and finally you will definitely certainly will get this answer at the end of your simplification, right? It is something s plus 1 by tau 1 plus s plus 1 by tau 2 by it is s plus right, s plus it is 1 by beta times tau 1 into s plus 1 by alpha times tau 2. This is what the expression for the transfer function. Very simple. It is a very simple actually. This is the very simple, and this is very important a ratio to be remembered, right? This is the transfer function of a lead lag compensator, lead lag or lag lead compensator circuit, s plus 1 by tau 1, where tau 1 is equal to, I will write for you here, where the tau 1, what is tau 1? It is the time constant. your tau 1 is nothing but time constant, right? So your tau 1 is equal to, where tau 1 is equal to, it is R1 into C1, time constant, as well as your tau 2 is equal to R2 and then C2, called as time constant actually, time constant, time constant. And similarly, what is alpha and then beta? What is alpha and then beta? Similarly, your alpha is equal to, here two parameters you can able to see, no, alpha and beta. What is alpha? Alpha is nothing but something, it is R1 plus R2 by it is R2. This is what alpha. Similarly, what is beta? Reverse actually, it is R2 by R1 plus R2. That's it. That's it. That is what your beta actually, right? And moreover, if you take the product alpha into beta, if you do the multiplication of these two, definitely alpha into beta is equal to 1. Alpha into beta, from these two, if you take the ratio of alpha into beta is equal to, definitely it will be 1, because both will be multiplied, right? Alpha into beta is equal to 1. So this is what simple, important things involved in this transfer function, right? So at this moment, you will just remember this formula and you definitely can simplify that. Okay, you definitely can simplify that ratio and finally you can bring this, right? This is the form of the transfer function of a lead lag network basically, right? Lead lag. So the main application of this lead lag network is that definitely in order to improve the steady state response of the system, this lead lag network can be employed in a control system, right? This is the very simple circuit, thereby you have seen the transfer function. Clear? So we will finish off this presentation here, and in the next presentation we will see the comparison of these three. What is a phase lead network? What is a phase lag network? And what is a lead lag or lag lead network? What are the basic important differentiations or various differences between these three we can see in the subsequent presentation. And definitely you will be expected the question based on these compensators in GATE as well as in UPSC IAS examination. Damn sure questions you will get, damn sure questions you will get. Definitely will expect at least 1 or 2 questions from these compensators, both in GATE as well as UPSC IAS. Very, very important topic actually. And they will ask you that in phase lead, what is the steady state response, or what is the gain of the amplifier, what is the bandwidth, what happens to the bandwidth. Okay, in the next presentation, I am going to explain you about the various parameters, how the parameters will be affected, like gain of the amplifier, like the bandwidth of the amplifier, how these will be affected with the introduction of this phase lead or phase lag and lead lag. With the introduction of these three, how the system performance or system parameters will be affected, thereby how its accuracy will be improved or what will happen to the circuit, that we will see definitely in this next presentation. It will be very interesting, very useful definitely, right? And I finish off here, and I wish you very wonderful day, and thanks for watching this video. Have a beautiful day.